1950. The war in Korea is on its way. Huge UN forces led by the United States act on the side of the capitalist South. A group of American F-80 Shooting Star fighters take off for a combat mission. Confident of their superiority, pilots do not expect any enemy attack.
Now 30 degrees left at 25.
All of a sudden, 3 silvery aircraft appeared in the sky attacking American fighters at high speed. The MiGs were superior in speed and maneuverability, and they soon shot down one of the shooting stars. The remaining American fighters quickly left the airspace of North Korea. That was the first in history air fight between jet aircraft in which Soviet pilots were victorious. A fighter is designated to have superiority over aircraft of any other class. Maneuverability and efficient armament are among its obligatory qualities. However, speed is one of the most important components of success. In order to reach it, throughout the fighter's entire evolution, designers were installing more powerful engines, updating aerodynamics, introducing different technical innovations. During the Second World War, the maximum speed of serial fighters significantly increased. However, the engine weight was way ahead of the power-to-weight ratio increase. Moreover, the propeller is capable of bringing aircraft only to a certain limited speed. Scientists and designers of the world-leading aviation countries acknowledged this problem almost simultaneously. The way out was found in the creation of a principally new type of engine. The working principle of such engine gave it its name, the jet engine. Here is how the concept was explained in a training film of 1947.
Посмотрите, как откатывается пушка при выстреле.
Look how the gun barrel recoils after the shot. This blowback feature of the firing arm makes the basis of the jet motion principle. If we take the barrel off the mount and put it on stabilizers, we shall have a primitive flying jet unit.
Мы получим простейший летательный аппарат с реактивным двигателем.
In hope of luck, research was conducted in several directions at a time. The main of them was with respect to the liquid propellant rocket LPR engines and the turbojet engines. In the LPR, working gases are created in the combustion chamber due to the chemical reaction between fuel and oxidizer available on board the aircraft. In the turbojet engine, air taken from the atmosphere is used in the fuel burning process. First jet engines development started in the USSR before the Second World War. However, the Germans and the British are by right considered to be the pioneers in this sphere. The first turbojet aircraft took off in Germany in summer of 1939. It was an experimental Heinkel 178. 2 years later, a Gloucester jet aircraft was put on tests in Great Britain. In result of further developments in this field, both countries had serial aircraft in 1944. They took part in combat activities of the Second World War. In the Soviet Union, developments of a jet fighter started in 1941. On the first day of the Great Patriotic War, Viktor Bolkhovitinov submitted an application to the Aviation Industry Ministry on the creation of a rocket fighter interceptor. The ministry replied to have the aircraft ready within a month. Within the designated term, the experimental BI-1 rocket fighter was put on tests. The Soviet first-born jet had a classical layout pattern with a straight wing. The liquid jet engine, designed by Leonid Dushkin, developed thrust of 1,100 kilograms. Flight tests were delayed due to the design group evacuation to the Urals, and the BI-1 performed its first flight on May 15, 1942. The aircraft was piloted by test pilot Grigory Bakhchivandzi. BI-1 managed to reach a fantastic by that time rate of climb of 82 meters per second. Without waiting for the tests to be completed, the aircraft was decided to be put on serial production. However, tests went on with great difficulties, the main of which were in connection with the liquid jet engine. The nitric acid making part of the fuel was corroding the pipelines and other elements of the aircraft construction. Any leak of this dangerous liquid threatened to turn into a fire or even explosion, and the fuel itself was enough for only 2 minutes of flight. But the trouble came from the other side. The next test flight to reach a speed of 800 kilometers per hour was scheduled for March 27, 1943. During the boost and climb, BI-1 suddenly started to dive and hit the ground. Test pilot Bakhchivandzi died. For the first time, scientists came across a new and dangerous phenomena. It became clear that with acceleration, the air starts to act somehow differently, as if an unknown force would not let the aircraft to go through. So the aircraft needed a different endurance calculation and a different aerodynamic scheme. However, the wartime requirements did not allow to conduct the relevant research works. Without going into the details of the wreck, the fighter's production was cancelled and the non-completed aircraft were deemed dangerous to fly and destroy. Further works in this direction restarted only in the end of the war. A rocket engine installed on experimental Lavachkin and Yakovlev piston engine fighters was used as a booster, increasing the aircraft's speed by an average of 150 kilometers per hour. An interesting idea was of a motor compressor engine, a combination of a piston and air-breathing power plant. In March 1945, such a combined engine accelerated the Mikoyan I-250 aircraft to a speed of 825 kilometers per hour. However, further works with the fighters with such power plants were deemed to have no prospects. It was clear that the future of aviation belonged to the turbojet engines, however, they were yet to be created. Developments in this direction were conducted in 1937 by designer Arkhip Lulka. However, the war that started soon did not allow to pursue the project. Therefore, some of the trophies taken after the war from Germany by Russian specialists were very useful. Among other things, German jet aircraft turned up in the Soviet Union. Changing crosses to stars, these aircraft first of all underwent detailed tests in the Air Force Research Institute. The main attention was given to Me-262. The government seriously considered an issue of copying this Messerschmitt and producing it in series. However, pilot Kochetkov was nearly killed during tests. The problem was the same as with BI-1, dragging into dive at high speeds. This was not the first accident with Me-262. The Germans faced this phenomenon several times. Finally, it was decided to design our own fighters but with the German engines. They were of two types, Junkers UMO 004 and B&W 003. Those engines, of course, had deficiencies, but there was no other choice. There was no engine of our own. Within the shortest time, engines were put into production at the Soviet plants. UMO was identified as RD-10, while BMW was called RD-20. The Cold War between the former Allies accelerated the wheel of the arms race. The new atomic weapons were also taken into account. Mass production of fighters became a vital necessity. Only they could not let the enemy's bombers enter the native airspace. Creation of a jet fighter was so important for the Soviet Union that the country's leadership assigned several design bureaus to this task. Design teams of Yakovlev, Mikoyan, Lavachkin and Sukhoi were put to work. Jet aircraft tests were scheduled for the first half of 1946. The terms were very tough. Under such circumstances, Yakovlev decided to save on the new framework development. Here is how he voiced his concept. We had a task of creating an aircraft in which only an engine would be new, while all the rest apparently would remain the same. The pilot would then be getting into well-familiar surroundings and would not feel any difference between the jet and the piston engine aircraft in flight and at takeoff and landing. Yakovlev took its well-known combat-tested Yak-3. Leaving the airframe practically unchanged, he installed a turbojet RD-10 engine instead of the piston one. The fighter was identified as Yak-15. However, while the said fighter was actually a jet modification of Yak-3, the I-300 of the Mikoyan Design Bureau was a completely new aircraft. The nose-wheel scheme, which then became classical for the Soviet jet fighters, was applied on this aircraft. Its armament was also impressive. Two 23mm and one 57mm cannons. The aircraft was equipped with two RD-20 engines. The new speed profile wing allowed to fly at over 900 kilometers per hour. The aircraft was identified as MiG-9. April 24, 1946 became an important date in the history of the Soviet aviation. The MiG-9 jet fighter test sample took off the strip of the Flight Research Institute at 11:12 a.m. Having made 2 circles over the aerodrome, the aircraft successfully landed. Test pilot Alexei Grinchik was satisfied with the aircraft. Within about a couple of hours, the jet engine roar was again heard over the aerodrome. Yak-15 took off at 1:56 p.m. The aircraft was piloted by test pilot Mikhail Ivanov of the Yakovlev Design Bureau. These aircraft were publicly shown in the same year at the traditional air parade in Tushino. On the next day, Stalin ordered to have 10 or 15 jet aircraft manufactured for the November parade at the Red Square. The leader's order was carried out with no delay. Within just a month and a half, in the beginning of October 1946, the first serial MiG-9 and Yak-15 started to arrive at airfields where they were put together and flown. By that time, in addition to the said aircraft, the first La-150 jet fighters arrived. They were supposed to be shown at the air parade as well. All was ready by November 7, but the new Soviet jet aircraft show did not take place due to bad weather. In spring 1947, MiG-9 and Yak-15 passed the state tests and started their service. The two-engine Su-9 and Su-11 of Pavel Sukhoy were also ready by that time. For the first time in the USSR, these aircraft were equipped with powder-started boosters, a drag chute, and the hydraulic actuators. The aircraft also had air brakes and an ejection seat. However, the Sukhoy and Lavochkin aircraft remained experimental. Air Force considered Mikoyan and Yakovlev fighters to be enough. Moreover, Yakovlev, having updated Yak-15, made its modification, Yak-17, differing from its predecessor by the nose wheel. This aircraft became the first Soviet jet aircraft supplied on export. Very soon, jet fighters started to oust their piston engine colleagues. Further progress in the aircraft industry now directly depended on the appearance of new engines, more lightweight, more powerful, and economic. However, aircraft designers had only 2 types of German engines at their disposal. And although the experimental Su-11 was equipped with the native TR-1 engines developed by Arkhip Lulka, they were very far from perfection. There was no time to wait until the native engines would reach the required characteristics, so Stalin was proposed to buy engines from the British. What fool would be selling its secrets, asked the leader in surprise. Nevertheless, in autumn of 1946, a delegation including Artyom Mikoyan and engines designer Vladimir Klimov went to England. The situation was peculiar for the fact that in spring of the same year, Winston Churchill delivered his famous speech in Fulton, giving the start to the Cold War against the Soviet Union. Surprisingly, but money once again turned to be beyond politics. The delegation bought not only 60 Rolls-Royce ready-made engines, but also the license for their manufacture in the USSR. This event made a great impact on the development of the jet aviation in the Soviet Union. Of course, with such engines available, the Soviet designers hurried to implement their capabilities. That's how the new Yakovlev fighter appeared. The aircraft successfully passed the state tests, showing the maximum speed of 930 kilometers per hour. The aircraft was put on service in 1949 as Yak-23. Significant increase of speed was the tendency in aviation at that time. A powerful jet engine assisted to such achievement, but did not solve all the problems. Increase of speed and phenomena related to that demanded radical reassessment of the flight aerodynamics and urged the scientists to resolve a number of complex tasks. Increase of the aircraft speed increases the air drag. The air, like a sluggish mass, would not let the aircraft through. One of the ways of decreasing the air drag is the application of the high-speed profiles and the swept wing form. Developments of the German scientists laid the basis for such works in both the Soviet Union and abroad. The Germans dealt with the swept wing already during the war. In the Soviet Union, such wing appeared first time in 1947 on La-160 prototype fighter. Its sweep angle reached 35 degrees. But the swept wing has not only positive features. The airflow at such a wing is both lateral and longitudinal. This results in a shock stall in the end of the wing, which diminishes the longitudinal stability of the aircraft. An innovation, the boundary layer fans, was used on La-160. They were installed on the upper surface of the wing to keep the air from flowing along the wing. Aerodynamic tests showed that this innovation was very efficient. Subsequently, aerodynamic fences were applied on many types of Soviet jet aircraft. Boundary layer fences were installed on the new Mikoyan I-310 fighter. On December 30, 1947, test pilot Viktor Yuganov took it into the air for the first time. Tests showed that the aircraft possessed outstanding flight characteristics. It reached the speed of 1,050 kilometers per hour and had a powerful armament, 137mm and 223mm cannons. The cannons were mounted on a special pod and could easily be lowered with a hoist for servicing and recharge. The fighter had an ejection seat. Air brakes were installed in the rear part of the fuselage to enhance maneuverability. In 1948, the aircraft was put in service as MiG-15. Lavochkin 15, appearing a bit later, became MiG-15's competitor. Both aircraft were surprisingly alike. There you see La-15, and this is the Mikoyan fighter. La-15's characteristics were inferior to MiG. It had less powerful armament, and the narrow wheel track made the takeoff and landing at a heavy side wind more complicated. That's why MiG-15 became the mass serial-produced fighter. Starting from the 1950s, MiG-15 was substituted by MiG-15 bis. This modification got a new VK-1 engine with a thrust increased up to 2,700 kilograms, designed by Vladimir Klimov. The space of air brakes was enlarged. All this allowed to improve the flight characteristics of the aircraft. Production of the UTI MiG-15 trainer started the same year. This two-seater dual-control aircraft became very popular among trainees and instructors. The flight crews tenderly called this aircraft a granny or a mummy. MiG-15 gained combat success in Korea. In 1950, when a military conflict ran high on the Korea Peninsula, the USSR and China came to help the northern communist Korea. Soviet aircraft units equipped with MiG-15 were covertly sent to Korea. The United States and their allies acted on the side of the southern Korea. The U.S. aircraft group was huge both in terms of quantity and types of aircraft. Appearance of the Soviet jet fighters was an unpleasant surprise for the Americans. Right from the start, the Soviet MiGs demonstrated significant superiority not only over the piston engine Mustangs, but over the Shooting Star and Thunderjet fighters. The only worthy competitor to MiG-15 in Korea was F-86 Sabre. The American aircraft was heavier than MiG and inferior in the rate of climb, ceiling, and armament, but was superior in horizontal maneuverability. More efficient air brakes and slaps made this aircraft more superior in the air combat. F-86 was significantly superior than MiG in terms of onboard equipment. Take just the aiming device with the ranging radar. Besides, the Sabre pilots flew in special garments, enabling them to overcome the G-factor in the air combat. However, the MiG-15 appearance in Korea significantly changed the balance of forces. American attack aircraft and bombers took no more risks flying without the F-86 cover-up. The most memorable was the air battle of October 23, 1951, which the Americans called the Black Tuesday. 10 American B-29 bombers were shot down by MiGs in that battle. Of course, Americans wanted to get hold of MiG-15 to find out the reason of its success. Similar hunt for the Sabres was performed by the Soviet side. In October 1951, Colonel Pepelyaev shot down F-86, which made an urgent landing on the North Korean territory. Soon the damaged aircraft was brought to the Soviet Union. Detailed research of the American fighter allowed to introduce some technical solutions to the Soviet aircraft construction. MiG-15 also got into the hands of the Americans. 3 months after the war, a North Korean pilot defected to South Korea on the Soviet aircraft. The aircraft underwent the most detailed examination in the United States. However, the Americans found no technical innovations applicable to their aviation. According to official data, the Soviet pilots shot down over 1,000 enemy aircraft during the fights in North Korea, while the Soviet Air Force lost only 335 aircraft. MiG-15 virtually conquered the right to be called the world best fighter of the beginning of the 50s. It became one of the symbols of the Soviet aviation. Within 10 years, USSR produced over 13,000 MiG-15 of different modifications, and with the account of the licensed manufacture in Poland and Czechoslovakia, the amount of this aircraft exceeded 15,000. No other fighter in the world had such a circulation. The MiG-15 success enabled the Mikoyan Design Bureau to obtain from the leadership of the country a kind of a carte blanche for the further improvement of this aircraft. In result, the military received the MiG-17 fighter with the wing sweep of up to 45 degrees. In the end of 1952, production of the new modification of this aircraft, MiG-17F, was started. Its engine was equipped with the afterburner chamber, a unit allowing to increase the thrust. Within the general tendency of the speed increase in aviation, the fighters were the first to approach the speed of sound. The jet engine allowed to come very close to it, but so far it was not possible to pass it over. The drag increased drastically at such speed. There were even doubts of whether a supersonic aircraft could be produced. Americans were the first to go over the sound barrier. This record belongs to test pilot Chuck Yeager, who in 1947 passed over the speed of sound on the X-1 experimental aircraft. In the USSR, tests in this direction started before the Korean War. To go over the sound barrier, the Aerodynamic Institute scientists, based on calculations and experiments, suggested to use a wing with a low thickness chord ratio and a sweep of 45 degrees and more. The first Soviet aircraft to reach the speed of sound was Lavochkin Aircraft 176. In 1948, Oleg Sokolovsky accelerated this aircraft to a speed of 1105 kilometers per hour, which was slightly over the speed of sound, or as aerodynamics say, was slightly over Mach 1. In those years, the aviation science and aerodynamics, in the first place, were on an uprise. The new solutions proposed by scientists were tested on the more and more new experimental aircraft. In 1952, Georgy Sidov put into the air a new SM-2 fighter of the Mikoyan Design Bureau. The aircraft was meant as supersonic, however the insufficient thrust did not allow it to overcome right away the sound barrier in the horizontal flight. This became possible only with the installation of the new RD-9B engines with the afterburner. The maximum speed reached 1,450 kilometers per hour, which was by 100 kilometers per hour more than on the first American supersonic fighter F-100 Super Sabre. In 1955, the fighter was put in production under the identification of MiG-19. Transition to supersonic speed required new constructional solutions. Traditional elevator was no more efficient at supersonic speed, so MiG-19 was equipped with an all-moving tailplane. The fighter became more maneuverable and easier to control. With such an update, it was renamed into MiG-19S. The task of creating a high-speed maneuverable aircraft capable of combating at short range from the aerodrome was resolved. But for the fighters of the 50s, more important was another task, to cover bombers on their way to the target and back. Bombers carrying nuclear weapons represented an important argument in the world politics. But in terms of range, fighters were way more inferior than bombers. It appeared that the escort would cover bombers only in the first, less dangerous part of the route, leaving the bombers alone over the enemy's territory full of all means of air defense. Supplementary fuel tanks did not fully resolve the problem. Research was started both in the USSR and in the United States. Americans, for example, tried to suspend a mini-fighter under the bomber, which was supposed to detach, if needed, from the carrier and cover it. The Yakovlev Design Bureau suggested a fighter with a switched-off engine to be towed by the bomber. Such system was called the Hobblers. You see the rare archive shots of the system tests. One may think that this is an in-flight refueling. In fact, the prototype Yak-25 is towed. In the event of an enemy's attack, the pilot would switch on the fighter's engine, detach, and enter into combat. Thereafter, it would hook up back to the bomber and fly on. Most of the projects of this kind on both sides of the Cold War front, due to various reasons, did not find continuation. However, the search for the solution went on. In 1953, the Flight Research Institute conducted the in-flight refueling tests. The MiG-15 BIS fighter was performing a hookup to the hose probe of the tanker. The tanker was a refurbished Tu-4 bomber. There were also tests with the MiG-19 in-flight wing-to-wing refueling. All such tests at that time did not go beyond an experiment. However, many years thereafter, the fighters in-flight refueling became a norm. Another direction of the fighter's development was the creation of an aircraft requiring a short takeoff strip or even no aerodrome at all. The explanation was simple. Dimensions, speed, and takeoff weight were growing. Airfields were becoming wider and longer accordingly, thus becoming a more and more vulnerable target for the potential enemy. An ejection takeoff appeared as an alternative. An aerodrome is a costly construction and they cannot be built everywhere in the country, while the system allowing to live without them seemed to have many advantages. Just imagine a fighter ejecting from a forest like a genie from a bottle, attacking the astonished enemy. The first ejection takeoff was performed by test pilot Georgy Shiyanov in spring 1957. The MiG-19 mounted on a mobile launch site was virtually shot into the sky with the help of a powder booster. After the test, the system was shown to Defense Minister Zhukov, but the Marshal replied skeptically, "Now you only need to create a system of landing without the aerodrome." It appeared that after the mission the fighter would have nowhere to go. If in the wartime it was possible to lose the aircraft, in the time of peace such system appeared to be too costly. The project was closed. Americans also conducted similar works and found them non-prospective. Specialization of fighters was more distinct in the 50s. Some aircraft were designated for maneuverable combat while the others for interception. The interceptor's task is to destroy the target in any weather, any time of the day, and at any range of speed and altitude. This task was becoming more and more actual. Since the end of the 40s and throughout the entire 50s, foreign reconnaissance aircraft simply crowded along the USSR border, sometimes entering the airspace of this country. Development of interceptors was performed by the Lavochkin and Mikoyan design bureaus. Soon prototype aircraft I-320 and LA-200 started to fly and even passed the tests. However, they did not go into production due to absence of a reliable radar, without which the aircraft was no more an interceptor. Basically, Soviet Union was way behind the West in terms of radar equipment for aircraft. In the West, radar started to be applied back in the years of the war. The local radar station for fighters was made only in 1950, but still it was so unreliable that it was practically not used. The war in Korea inspired progress in this field. It became clear that a fighter without a radar was initially a no-win. Izumrud became the first Soviet successful radar. It was installed on the MiG air defense interceptors. It was capable of locating bombers at a range of 11 kilometers. Subsequently, the modernized Izumrud was installed on a supersonic MiG-19P. In the beginning of the 50s, the Yakovlev Design Bureau came up with the initiative of making a barrage interceptor capable of performing long-term patrolling at a long distance from the aerodrome. The Mikulin's AM-5 small-size engines with good thrust were best for such an interceptor. To extend the flight range, they were installed under the wing, which enabled to locate more fuel in the fuselage. A bicycle landing gear became a characteristic feature of this aircraft, allowing to reduce its dimensions and save on the construction weight. This interceptor could stay over 3 hours in the air, while the new Sokol radar was detecting targets at a distance of up to 30 kilometers. It was an excellent result for that time. The serial version was indicated as Yak-25. The same identification had the Yakovlev's prototype straight-wing fighter. Now it had an interceptor namesake, another Yak-25. In 1955, interceptors started to join the army. Pilots liked the aircraft a lot. It was pleasant to fly and had excellent takeoff and landing characteristics. As the pilots joked, the self-drive and self-land. In the first half of the 50s, progress of the Soviet scientists and designers in the field of aerodynamics and engine construction allowed to approach a double speed of sound. Such flight conditions dictated new aircraft layout. The most perspective was the delta wing. As compared to the swept wing, it had a more rigid construction, which is no less important at high speed. Besides, such wing could carry more fuel. In 1953, the Mikoyan Design Bureau started production of the light frontline fighter. Having no experience of the delta wing utilization, the Mikoyan Design Bureau decided to use the well-proven chess combination E2-E4. E2 was the index of the swept wing fighter, while E4 was the index of the delta wing fighter. The comparative tests showed advantages of E4. It was clear that the new fighter will have a delta wing. Aircraft systems and construction update started. The air intake lip became sharper and the cone inside of it became extensible. Specifically for the Mikoyan aircraft, a new ejection system was tested. It had a unique design. During ejection, the canopy and the seat served as a kind of a capsule covering the pilot from the abram air, and then it automatically separated from the seat. In 1957, the aircraft was issued in a limited edition of 10 pieces under the name of MiG-21. Very soon, different modifications of this fighter became familiar to the whole world. The potential of this aircraft enabled it to stay in service in many countries until the 21st century. However, the path of this outstanding aircraft could have terminated at the very beginning. Su-7, a swept-wing fighter built by the Sukhoi Design Bureau, became the MiG-21 competitor. In 1956, for the first time in the Soviet Union, this aircraft exceeded the speed of sound twofold. The Sukhoi fighter was also superior in altitude. The future of the Mikoyan aircraft became doubtful. The aircraft's future was saved by the new two-shaft engine designed by Tumansky. Thanks to it, the MiG-21 flight characteristics became much better. Armament was added. Pylons for bombs or blocks of aircraft rockets were put under the wings. With the above-mentioned changes, the aircraft was put on service as MiG-21F. Quick progress in the jet era could not but touch upon the fighter's armament. By mid-50s, the air-to-air missiles appeared in the arsenal of American aircraft, which significantly increased their combat efficiency. RS-1U became the first such rocket in the USSR. Its identification can be translated as First Guided Rocket. It was targeted upon a radio beam from the fighter's onboard radar and had a range of 3 kilometers. In 1956, MiG-17 interceptors were armed with a new armament. Next modification of this missile had twice longer range, and they were put on supersonic MiG-19 PM. Of course, the first missiles were far from perfect. Their application was like shooting in a rifle range. Missile could hit only non-maneuvering air targets. An unbelievable event gave an impact to the development of the rocket armament of the Soviet fighters. In autumn of 1958, in the course of combat activities between aviations of China and Taiwan, an American Sidewinder missile fired from a Taiwanese Sabre was stuck in the Chinese MiG-17 and did not explode. MiG-17 managed to land with such an American splinter. Soviet experts hurried to friendly China. Research showed that the Americans managed to create a lightweight, compact, and easy-to-operate air-to-air missile. The infrared homing head could easily hook up to the tail of the aircraft under attack, and the missile would catch up with it despite the pilot's maneuvering. The USSR decided to copy this Sidewinder. The homing head was copied as is, while the payload was decided to be made more powerful. The Soviet version of the missile was called K-13, and it became part of the new MiG-21 modification armament. The fighter was identified as MiG-21 F-13. MiG-21 PF became the next large series modification. Its main peculiarity was that the new radar enabling it to perform under heavy meteorological conditions and at night. Soon the MiG-21 PFM was put into production. For the improvement of its takeoff and landing characteristics, such aerodynamic novelty as the flaps boundary layer blowing was applied. The MiG-PF and PFM modifications concept of those years did not include guns. The close air combat at high speed was thought to be practically impossible, and the flights were assumed to be conducted only with the use of guided missiles. The war in Vietnam, which started in 1965, allowed to test the aircraft in real combat conditions. The main mixed competitor was the American F-4 Phantom. Possessing more powerful missile armament and a more enhanced onboard radar, it was significantly inferior to MiG in maneuverability. However, a good overview from the cabin and a second crew member capable of controlling the situation made Phantom an adequate enemy. Vietnam proved the necessity of cannons. Close maneuverable fights took place rather often. Since neither MiGs nor Phantoms had any built-in guns during the Vietnam War, they started to use gun pods. However, the most efficient conduct of the air combat was considered to be the simultaneous use of two types of aircraft. Thus, MiG-17s were blocking the entire altitude range up to 2,000 meters. Having higher pre-sonic maneuverability, they were squeezing Americans up, where they were awaited by MiG-21s. The Vietnam War experience provided a lot of useful information to the Soviet engineers and designers. However, further aircraft improvement went on in mainly two directions. The first was the armament enforcement with the modern missiles, which had a semi-active homing head and could cover targets in any weather conditions. The second was the new radar stations, allowing to detect targets at longer distances. In the mid-60s, MiG-21 became the main combat aircraft not only in the Soviet Union but in many socialist countries. Therefore, a dual-control version of this aircraft, MiG-21U, was created for the purpose of training. Many generations of cadets and pilots mastered their flight skills on this aircraft. The system of automatic flight parameters registration was for the first time applied on this dual-control aircraft. It was then implemented on combat aircraft. This system became a kind of the black boxes prototype mentioned in any report of air accidents. The MiG-21 fighter's family holds a lot of world records. In 1961, 16 days after the Gagarin's flight into space, pilot Georgy Masalov reached an indeed a cosmic height of 34 kilometers 714 meters. This became possible thanks to installation of an additional liquid booster of MiG-21F. This absolute world record outlasted 12 years. Without doubt, MiG-21 is one of the world's most known fighters. As to the number of modifications, which is 30, it has no match. It was put on service in 49 countries of the world and still serves in some of them. In the second half of the 50s, the threat of a nuclear strike over the economic and military centers of the USSR became more than real. Air defense was becoming the most important task. The air defense complexes of that time were yet developing and did not provide any guarantee against breakthrough of the enemy's striking aircraft. The main role in the protection of the airspace was placed on interceptors. June 24, 1956, air parade in Tushino. Everyone's attention was caught by a whirling away aircraft with a delta wing. It was Sukhoi T-3 prototype interceptor. First, Almaz radar was installed on this interceptor. However, two huge antennas decreased aerodynamics of the aircraft. Therefore, a new radar was installed, which antenna was placed inside the ram-type air intake cone. The new aircraft was identified as T-43. On October 10, 1957, test pilot Vladimir Ilyushin put it into the air. In the very first flights, the aircraft reached a speed of 2,200 kilometers per hour and an altitude of 21,500 meters. Within 1 year, it was decided to make a whole interception complex on the basis of this aircraft, including the aircraft itself, the onboard radar, the missile armament, and the on-ground targeting system. The first Soviet interception complex was put into service in 1960 under the name of Sukhoi 951. 2 years later, the Air Defense Aviation obtained a more sophisticated complex. Su-11 became its basis, equipped with a more powerful aerial radar, with a target hookup range of 20 kilometers, which was twice as much as of its predecessor. Su-9 and Su-11 were the most high and fast-flying aircraft of the air defense aviation of this country in the 60s. They served for over 20 years. In the same 60s, the Sukhoi aircraft were assisted by Yak-28P interceptors. Made on the basis of a supersonic bomber and equipped with the Ariel-D radar, they were supposed to intercept enemy aircraft at low and mid altitudes. But for targets destruction at longer range, a completely different type of interceptor was required. The Lavochkin Design Bureau attempted to make such an aircraft. According to the project, LA-250 was supposed to reach speed of 1,600 kilometers per hour and hit supersonic targets with its missiles at an altitude of up to 20,000 meters. Brought to tests one after another, these aircraft crushed, and in 1959 all works on this topic were terminated. A new long-range interceptor was started by Andrei Tupolev. The fighter was identified as Tu-128. It succeeded all other fighters in the world as to its dimensions and weight. This 43-ton aircraft was equipped with the most powerful radar of that time, the Smerch. It located targets at a distance of 50 kilometers. R-4 missiles of half a ton each could destroy targets not only at catch-up but also at reciprocal courses. The reciprocal course attack was for the first time performed in the USSR. In 1965, Tu-128 was accepted for service. In the NATO classification, it was called the Fiddler. It was indeed the first trialing of the air defense aviation. July 9, 1967, Domodedovo Airport. The Aviation Fest was on its way. Hundreds of aircraft, thousands of parachute jumpers, aerobatics by serial aircraft. The best samples of the jet-era aviation fascinated by their strength. There were the supersonic Su-9 and Su-11, the Yak-28P interceptors. Tu-128 trios effectively passed over the audience. Soviet designers watched their birds fly. Everyone is carried away by the group aerobatics on MiG-21. Spectators admire the flights and wait for something special. New developments should be shown on the 50th anniversary of the revolution, and they lived up to their expectations. The supersonic fighter will be called MiG-23. Its wing changes its sweep right in the air. All of a sudden, a group of unusual aircraft passed soundlessly over the audience. This was MiG-25. It will become known as the fastest and the most high-flying combat aircraft in the world. Only 20 years passed since the creation of the jet engine, and so many aircraft have been made. Their image has changed drastically. Look at the speed and altitude at which they fly. But still, this is only a beginning. New aircraft, new speeds and altitudes and new capabilities are ahead. Struggle goes on in the sky. The struggle for superiority. Years in this sphere. The first turbojet aircraft took off in Germany in summer of 1939. It was an experimental Heinkel 178. 2 years later, a Gloucester jet aircraft was put on tests in Great Britain. In result of further developments in this field, both countries had serial aircraft in 1944. They took part in combat activities of the Second World War. In the Soviet Union, developments of a jet fighter started in 1941. On the first day of the Great Patriotic War, Viktor Bolkhovitinov submitted an application to the Aviation Industry Ministry on the creation of a rocket fighter interceptor. The ministry replied to have the aircraft ready within a month. Within the designated term, the experimental BI-1 rocket fighter was put on tests. The Soviet first-born jet had a classical layout pattern with a straight wing. The liquid jet engine, designed by Leonid Dushkin, developed thrust of 1,100 kilograms. Flight tests were delayed due to the design group evacuation to the Urals, and the BI-1 performed its first flight on May 15, 1942. The aircraft was piloted by test pilot Grigory Bakhchivanji. BI-1 managed to reach a fantastic by that time rate of climb of 82 meters per second. Without waiting for the tests to be completed, the aircraft was decided to be put on serial production. However, tests went on with great difficulties, the main of which were in connection with the liquid jet engine. The nitric acid making part of the fuel was corroding the pipelines and other elements of the aircraft. November 1950. The war in Korea is on its way. Huge UN forces led by the United States act on the side of the capitalist South. A group of American F-80 Shooting Star fighters take off for a combat mission. Confident of their superiority, pilots do not expect any enemy attack.
Contest now 30 degrees left at 25.
All of a sudden, 3 silvery aircraft appeared in the sky, attacking American fighters at high speed. The MiGs were superior in speed and maneuverability, and they soon shot down one of the shooting stars. The remaining American fighters quickly left the airspace of North Korea. That was the first in history air fight between jet aircraft in which Soviet pilots were victorious. A fighter is designated to have superiority over aircraft of any other class. Maneuverability and efficient armament are among its obligatory qualities. However, speed is one of the most important components of success. In order to reach it, throughout the fighter's entire evolution, designers were installing more powerful engines, updating aerodynamics, introducing different technical innovations. During the Second World War, the maximum speed of serial fighters significantly increased. However, the engine craft construction, Any leak of this dangerous liquid threatened to turn into a fire or even explosion, and the fuel itself was enough for only 2 minutes of flight. But the trouble came from the other side. The next test flight to reach a speed of 800 kilometers per hour was scheduled for March 27, 1943. During the boost and climb, BI-1 suddenly started to dive and hit the ground. Test pilot Bakhchivanji died. For the first time, scientists came across a new and dangerous phenomena. It became clear that with acceleration, the air starts to act somehow differently, as if an unknown force would not let the aircraft to go through. So the aircraft needed a different endurance calculation and a different aerodynamic scheme. However, the wartime requirements did not allow to conduct the relevant research works. Without going into the details of the wreck, the fighter's production was cancelled and the non-completed aircraft were deemed dangerous to fly and destroy. Further works in this direction restarted only in the end of the war. A rocket engine installed on experimental Lavochkin and Yakovlev piston engine fighters was used as a booster, increasing the aircraft's speed by an average of 150 kilometers per hour. An interesting idea was of a motor compressor engine, a combination of a piston and air-breathing power plant. In March 1945, such a combined engine accelerated the Mikoyan I-250 aircraft to a speed of 825 kilometers per hour. However, further works with the fighters with such power plants were deemed to have no prospects. It was clear that the future of aviation belonged to the turbojet engines, however, they were yet to be created. Developments in this direction were conducted in 1937 by designer Arkhip Lulka. However, the war that started soon did not allow to pursue the project. Therefore, some of the trophies taken after the war from Germany by Russian specialists were very useful. Among other things, German jet aircraft turned up in the Soviet Union. Changing crosses to stars, these aircraft first of all underwent detailed tests in the Air Force Research Institute. The main attention was given to Me-262. The government seriously considered an issue of copying this Messerschmitt and producing it in series. However, pilot Kochetkov was nearly killed during tests. The problem was the same as with BI-1, dragging into dive at high speeds. This was not the first accident with Me-262. The Germans faced this phenomenon several times. Finally, it was decided to design our own fighters but with the German engines. They were of two types, Junkers UMO 004 and BMW 003. Those engines, of course, had deficiencies, but there was no other choice. There was no engine of our own. Within the shortest time, engines were put into production at the Soviet plants. UMO was identified as RD-10, while BMW was called RD-20. The Cold War between the former Allies accelerated the wheel of the arms race. The new atomic weapons were also taken into account. Mass production of fighters became a vital necessity. Only they could not let the enemy's bombers enter the native airspace. Weight was way ahead of the power-to-weight ratio increase. Moreover, the propeller is capable of bringing aircraft only to a certain limited speed. Scientists and designers of the world-leading aviation countries acknowledged this problem almost simultaneously. The way out was found in the creation of a principally new type of engine. The working principle of such engine gave it its name, the jet engine. Here is how the concept was explained in a training film of 1947.
Посмотрите, как откатывается пушка при выстреле.
Look how the gun barrel recoils after the shot. This blowback feature of the firing arm makes the basis of the jet motion principle. If we take the barrel off the mount and put it on stabilizers, we shall have a primitive flying jet unit.
Мы получим простейший летательный аппарат с реактивным двигателем.
In hope of luck, research was conducted in several directions at a time. The main of them was with respect to the liquid propellant rocket LPR engines and the turbojet engines. In the LPR, working gases are created in the combustion chamber due to the chemical reaction between fuel and oxidizer available on board the aircraft. In the turbojet engine, air taken from the atmosphere is used in the fuel burning process. First jet engines development started in the USSR before the Second World War. However, the Germans and the British are by right considered to be the pioneers